Very good morning. Previous sections we have discussed about fundamental of electromagnetic field and vector analysis. This section we are going to discuss about coordinate system. We have three types of coordinate system, namely Cartesian coordinate or rectangular coordinate, cylindrical coordinate or circular coordinate, and spherical coordinate. Just view this figures, we can easily understand this structure of different coordinates. For the Cartesian, the best example is rectangular object. For the cylindrical coordinate, the example is a cylinder. For the spherical coordinate, the example is a sphere or ball. This coordinate systems, we are dealing in three-dimensional axes. The axes are x, y, and z. These three axes are mutually perpendicular to each other. That means the angle between x and y is 90 degree. Similarly for y and z and x. Then about this red mark line and the point P, we will discuss in the forthcoming slides. Next, coordinate system. The axis, we are dealing in three-dimensional axis. One is an x-axis, y-axis, and z-axis. This can be explained with the help of fingers. Just take your finger like this. This is a center finger is indicating the x directions. Forefinger is indicating the y directions. And this thumb finger is indicating the z directions. Here, it is feel that somewhat confusion in these axis directions that will be explained with the help of a corkscrew rule, or we can just imagine this one plane surface or the table. We are making the hole in that. Now the surface, this is an x and y is the surface, and the direction of this screwing is an z directions. The surface is an x and y. Cartesian coordinate system. This is x-axis, y-axis, and z-axis. Just consider a rectangular object which is placed like this. This is the length, this is the width, and this is the height. The length of the box is indicating the x directions, and the width of the box is indicating the y direction, and the height of the box is an z directions. If you want to mark point P anywhere in this rectangular object, we require the three rectangular object to find out this. So it may be like this. So here is this blue color box, it may be the x direction. The green, it may be a y direction. For the height adjustment, it may be this color. So using this three rectangular object movement, we can find out or we can mark any point P in the given object. Now for this rectangular object, it consists of the 6 surfaces. So we are generally saying that top and bottom, front and back, then one side, that is left hand side and right hand side. Here, this is the considered as a rectangular object. This bottoms is an xy plane because the bottom surface, it consists of only x and y value and z is the constant. So we are saying that which is called as an xy plane or z equal to 0 plane. This is a top and bottom side of the rectangular object. Next one is an front side. Just take this is a front side. You can form this surface with the help of only the two values y and z, and x value is constant for the front side. The same thing is going to appear for the back side, but the x value is on higher values. Similarly, coming to the side, this is formed only this value of z and x and y equal to 0 on one side. The other side is on y is the maximum values. So if the plane is formed between these two variables x and y, it is called as an xy plane or z equal to 0 plane. Students, be clear because most of the problems they may be given that it is an xy plane or z equal to 0 plane. Both are same. Similarly for yz plane or z equal to 0 plane, zx plane or y equal to 0 plane, both are same. Now we will analyze about Cartesian coordinate system. Just consider the rectangular object. It have changes in all direction. The change in magnitude in x direction is a dx and y direction is an dy, z direction is dz. Due to these changes, what is the effect of length, area and volume? The change in length, it is an dl. The dl sometimes called as an differential length. This is an addition of all the direction of changing quantity. So this is a dx is an x direction changes value, y is an y direction changes value, and dz is an z direction change in value. Now this x cap, y cap and z cap, this is the direction of respective axis. So previously we maybe used ax, ay, az, but for the coordinate systems and for the problem solving, we are going to use the notation either x cap, y cap and z cap or ax, ay, az, and sometimes maybe using the notation of ijk. So whatever may be the notations, but it is the direction is indicating. Coming to this area, we know the fundamental formula for area, length into breadth. Take this x surface. Here is the surface is formed between the two values y and z. So here is the y value is an dy and z value is dz. Therefore, the value of an area is dy into dz. But this area has a direction. The direction is x directions. So the x direction is an x cap. So if it is the back side, in the same thing going to appear, but here is you are going to put it on minus side. Coming to the y side surface area analysis. This is the y side surface area analysis. This surface is formed between x and z values So the x direction value is dx and z direction value is an dz and the direction is an y. So this is marking here. Similarly for these z directions. For the volume, we are very familiar about this volume of this rectangular object. The unit is an meter cube. Therefore, just we are multiplying the three values x, dx, dy and dz. Again, just understand the concept here. Length, it has a direction, so it is a vector. Area, it has a direction, so it is a vector. Volume, it does not have direction, so this is a scalar quantity. Now it's a time to write the vector, differential length and a differential volume for the given vector ax into ax plus ay into ay plus az into az. It's time to you just write the differential length, differential area and differential volume. Previously, this is the given vector. For this vector, you are written this answer. For the differential length, this is a differential length vector representations. This is the magnitude of that vector length. Then for the surface, this is the answer. For the volume, this is the answer. Now we will discuss cylindrical coordinate system. For the cylindrical coordinate system, the example is the cylindrical object. This is a cylindrical object. Here, the radius of the cylinder is in x direction. The circumference of the cylinder is in y direction and the height of the cylinder is z direction. Now, you can discuss here the radius is in meter. The circumference, this is the angle. Then the height of the cylinder is in meters. So that's why we are saying that rho or r, it may be the use of the notation here, but most probably we are using the standard notation is rho. So rho in meter, and pi, that is the circumference, that is in degree, and height of the cylinder in meter. So the same way you can represent the vector a rho into a rho plus a pi into a pi plus az into az. For this you want to write the differential length, differential surface and differential volume. Here the unit of rho is in meter, so you can directly take d rho into a rho, and for this pi is unit is in degree, so you want to convert degree into meter. So you know the concept of an arc length. So this is the radius, this is the circumference. Here this is the circumference, this length we require. So the radius is an r and this may be the starting point, this may be the ending point. We required this length, we does not require the angle for this. The length is an s, which is equal to r into theta, arc length concept here. Now, instead of this r value, we have an rho, then the change of circumference is an d pi. Then for the height it is an dz into az. So here is also you want to take the magnitude of this, just ditto of the previous case. Now to mark the point P, we required the three objects here. The one is an cylinder, the next one is an rectangular plane, and third is also the rectangular plane. For marking the radius, we required an cylinder. For marking the pi and z, we required an rectangular plane. Now the students can practice the same thing in the white paper. Next, just imagine this and this figure. This is a rectangular, this is an cylindrical. Here, while comparing these two objects, in the z direction is remains same. Only the x and y direction of a rectangular object is forming this r and pi. So this is a conversion process because this is a x and y, this is the radius r, this is the angle. The angle is starting from an x to y directions. So now the x value is equal to r into cos pi, y value is equal to r into sin pi. This is a simple mathematical formula. Now next one is an spherical coordinations. With the help of an cone, cylinder and one rectangular surface, we are forming this. So now all are requested to take the object and we will mark the point. From the handout, we are coming to the conclusion. So this is the final table for an coordinate systems. So unit, vector, differential length, differential surface and differential volume and the ranges. So you are marked in the paper. The same thing can be practiced for this solving the problem. For the conversion, that is, you have the point in Cartesian coordination. What is the equivalent conversion of this point in spherical coordinations? So again here is, you take the paper and you make a small hole in the paper and roll it in the cylindrical shape and find what is the conversion process takes place. There is a changes, that things you want to find it. Now this is the, you can convert, you know the point in one coordinations, absolutely you can convert to other coordinations. So this is the formula. We will practice in the paper, then we will solve the problems.